Okay, so this is the PowerPoint on current and potential difference. First of all, what is current? Current is how we measure the rate of flow, which means how much is flowing per unit of time, or how much is flowing per second. The rate of flow of electric charge, so how much electric charge is flowing per second past a point in a circuit. Now, electric charge we measure in coulombs and current we measure in amps. So it's the number of coulombs passing a point in an electric circuit per second. Now, how do we measure it? Current is measured in amps using an ammeter, and the ammeter has to be in series in the circuit. It has to have the current flowing through it to be able to tell how much current is flowing. And the person who we named the amp after is Andrea Ampere, and the real name for amp is Ampere, but we shorten it to amp usually, and he's one of the first scientists that studied electricity. So 1 amp of current is 1 coulomb of charge flowing past a point in the circuit per second. 5 amps would be 5 coulombs of charge flowing past a point in the circuit every second. 10 amps could be 10 coulombs per second, or it could be 20 coulombs every 2 seconds. 20 divided by 2 is 10. So potential difference is a measure in the difference in the amount of electrical potential energy between 2 points in the circuit. It's the difference between how much energy the current is carrying between 2 places in the circuit. So the cell will give energy to the current, and a bulb will take energy away from the current. Now, to measure this, we use a voltmeter, and the voltmeter has to be connected in parallel. So it's connected to 2 different places in the circuit because it has to measure the difference in the amount of energy that the current has between these 2 different places in the circuit. Another way of thinking about voltage is how much force is pushing the current around the circuit. 1 volt gives 1 joule of energy per coulomb of charge. 1 volt is 1 joule per coulomb of charge. 12 volt battery will give 12 joules of energy to each coulomb of charge. Think about mains electricity, 240 volts gives 240 joules of energy for each coulomb of charge. So obviously the more energy you give the charge, the more dangerous it's going to be for us. So how can we can make models of electric charge and the flow of charge in the circuit. Here what we have is water going around a circuit. Now, water would represent the electrons or the charge in the circuit, because electrons have charge. So the water represents electrons or represents charge in the circuit. Here, this part, the pump, is what pushes the water or the charge around the circuit, and the wheel is like a component. A wheel is something that is doing something, like a bulb in the circuit. So the energy is given to the water here in the pump, and it's being used to turn the wheel there. The height of the water in this model represents how much energy the water has. Here the water gets pushed up a slope. Around the top it has energy, and then as it falls back down the slope, it's giving that energy away to the water wheel. And here on the way back to the pump, it's low down, so it doesn't have much energy. The water loses energy at the wheel, and it gains energy here at the pump. So if we were to measure the difference in electrical potential energy, or the voltage, we'd be measuring a difference in height between here before the wheel and here after the wheel. So how do we provide energy for the current in a circuit? We use something like a battery or a cell. Now, some people sell think that a cell creates electricity. It doesn't. A cell contains energy, chemical energy. It's a chemical reaction inside the cell that produces a potential difference. It gives energy to the current in the cell. Now, if current can't flow through the cell because there's not a complete circuit, nothing happens. Battery stores the electrical, stores the chemical energy for a long time. But if we connected this up to a bulb, so we gave it a circuit and the current could flow, the chemical energy in the cell is going to get transferred to the electrical current, and then in the bulb it's going to get transferred from the electrical current to light or heat. Now, we often call these batteries. These ones are individual cells, and a battery is a series of cells connected up one after the other. Like car battery is a battery of cells. It's a number of different cells connected one after the other. If you connect them up in series like this, the potential difference adds up. So this series of cells in the car battery are connected in series and they add up to give 12 volts. 12 volt car battery has 6 2-volt cells inside its case. So using more cells in the battery increases the voltage. Here we've got 1.5 volts. Here we've got 2 cells, one after the other in series. So we will have 3 volts. And here we have 3 cells connected in series, so we have 4.5 volts. Now you can carry on and do your Google Docs and your quizzes.